remember when we did arithmetic sequences, they look like this. Okay? And if this was arithmetic, what is my common difference? My common difference was 3. Yep. My a sub 1 was 1. So my formula, if you remember, was a sub n equals, remember this? A sub 3 times n minus 1 plus 1. Like that, it was your common difference times n minus 1 plus 1. Alright, so today, this was when you were adding to each one, right? Alright, so today, geometric sequences is going to be when you're multiplying by something. Okay? So, geometric sequence is a sequence of numbers in which the ratio, because now instead of a common difference, we're going to call it a common ratio. Remains the same. We find our common ratio, okay, by dividing, what do we divide? We divide each term by the previous term. Alright, so if I'm looking at number 1, okay, is this a geometric sequence? Evan, get your head up. Okay, what are they doing? They're multiplying by 5. So this is a yes. My ratio equals 5. Because every time they're multiplying by 5. How about number 2? What are they doing? Okay, so they're dividing by 3, but we need to know what they're multiplying by. If they're dividing by 3, they are multiplying by 1/3. So we're going to call that ratio 1/3. Okay, if they're dividing by 3 every time, okay, and this is a quick way that you can do it. Grab your calculators. Okay, if you can't figure out what your common ratio is, take your second term and divide it by your first. So take 45 divided by 135. And what do you get? 0.3 repeating, which is 1/3. Okay, remember 0.3 repeating is 1/3, 0.6 repeating is 2/3, right? 2 common decimals that you should know fractions to. Alright, how about number 3? What kind of a sequence is number 3? It's arithmetic, because what are they doing? They're adding 6 every time. Yep. Right?
No, that's not right.
6 plus 6 is 9 plus 8.
Oh. Are they adding 12? What are they doing? They're adding 12, and then adding 6, and then adding 6? Whatever. Alright, how about this next one?
Yeah.
Yes. What are they multiplying by? -2 every time, yep. So if it switches from negative to positive every other one, you know your ratio is going to be negative. Because this deals with exponents, and you'll see it when we do our formula, that this one has to do with exponents. So we did arithmetic when we were doing lines because that's linear. Okay, and we're going to do geometric when we do exponents because that's exponential. Okay, that's our reasoning behind it. How about number 5? What are they doing?
Multiplying by 1/2.
Multiplying by
Negative 1/2.
negative 1/2. There you go. And number 6? Yep, multiplying by 4 because my sign is staying the same. Okay, not so bad, right? Alright, so now we gotta find our next terms. So in order to find my next terms, I gotta figure out what they're doing. Multiplying by negative 3. So take 63, multiply it by negative 3,
Negative 189.
negative 189. Take negative 189, multiply it by 3.
567.
Take 567 and multiply it by negative 3.
Negative 1,801.
Now, what you guys got, you should be participating in this. Exercise your fingers a little bit. All right, so what's happening in number 8? Times it by 1/4. How'd you figure that out, Vance? Yeah, it's 768 divided by 3072 and got that 0.25 or that 1/4, and so we're multiplying by 1/4 every time. So 192 divided by 1/4 or times 1/4? 48 times 1/4? 12 times 1/4? 3. How's the next one? Multiplying by what? 1/2. All right. So 2 times 1/2? 1. 1 times 1/2? 1/2 times 1/2? Good. No, I want that one in fractions. Okay, and what are they doing in number 10? Multiplying by 5, so negative 125 times 5? Negative 625 times 5? Negative 31.5 times 5?
Negative 15,625.
Whew, now we're getting up there. That was fun. All right. Our formula, right, is, remember how in arithmetic we used A's? I suppose we're going to use in geometric. So we have G sub n. Oh, here. G sub n equals G sub 1 times the ratio to the n minus 1 power. Huh? G's? I'm saying G sub 1. Alright, so my G sub 1 stands for what? My first term. My R stands for my common ratio, yep. That just means the term that you're looking for. So when we move on to this, they're going to say, and they have an A here for, it's a typo. So this G sub 7, that's, so when I say what's G sub 7, that's what we're looking for. Okay? So I'm going to break formula here. It's G sub n equals, what is it, G sub 1 times the ratio to the n minus 1, right? Alright, so what is my G sub 1? 3. What's my common ratio? What? 3 because we're multiplying by 3. Alright, so let's write our formula. G sub n equals 3 then put your common ratio, it's gonna help you to put it in parentheses. So times, what's my ratio? 3 to the n minus 1. So that's what my formula looks like. Now, they want us to find g sub 7, okay, or the 7th term, right? So what am I putting in for n? Putting in 7 for n, so what's my exponent going to be? 6, because I always got to subtract 1, right? Okay, so 3 times 3 to the 6th power. So remember, you got to go 3 to the 6th power first, and then multiply by 3. 2,187. So you guys got it?
Yep.
All right. All right, so number 12, what's my common ratio? -5. Huh? I know, everyone.
One is here.
Who's here on Fridays? G sub n equals, what's my first term? -4. Everybody, you should be paying attention to this rather than pushing buttons in your calculator. We've had this discussion. Times, what's my common difference? -5 to the, well, no, n minus 1, because we want the formula first. Okay, when we're figuring it out, now you're right, now we're going to put 6 in there for you. Now you can start pushing buttons in your calculator. Because we have -5 to the 6th power. Now remember to put that in parentheses in your calculator. Because we're going to get a positive, some big number. And then you have to multiply it by what? -4, and we get, we shouldn't get a positive. Negative what? 62,500. That -5 sounds, gotta go in parentheses. Huh? Yep, so you gotta go -5 to the 6th power. Oh, so you were telling me what that was? Okay, gotcha. Alright. Everybody do number 13. What's my ratio?
Hold on, real fast.
What? So just figuring out the ratio?
Oh,
That's all I want. That was my only question. Well, no, I want you to continue to do the rest of the problem. I was just making sure people had the ratio figured out.
thought you just solved it.
Well, we'll do that as well. Okay, because the first part of this problem, remember, is that you have to write the formula. So everybody should have the formula written on their paper in terms of G sub n. So it should look like G sub n equals 400 times 1/2 to the n minus 1. Everybody's got that? What's going in to my exponent? 6 is going in for my exponent. So 1/2 to the 6th power, and you'll get a decimal. That's okay. And then multiply it by 400, and we get
6.25.
or 6.25. That's a really good question. Either way, Trey. Either way. What am I doing it for? So my ratio is 5. My formula, Najma, is what? G sub n equals 1, yep, and then in parentheses, n, and minus 1, there you go. When you're figuring it out, you can put a 6 in there. So 5 to the 6th power is 15,625 times 1 is 15,625. Okay, are you good with those, or should we do a couple more? Okay, all right. Last ones then, before I let you work, is this guy. Okay, when you're talking real life application, I would make your ratio as a decimal. Okay, so in this case, take your 8,000 divided by 10,000, and you get 0.8. All right, so my G sub 1 was 10,000 times, what's my ratio? 0.8 to the n minus 1. What does that look like? That looks like exponential decay, doesn't it? Okay, it's going to look very similar when you make this as a decimal. So after 10 years, what am I plugging in for that? A 9, yep. So you're taking 0.8 to the 9th power times 10,000. And how much is my car worth after 10 years? 1,000?
Yeah.
1,000 what? Oh, car's not gonna do it.
What brand new car costs 10 grand?
Well, they didn't say it was a brand new car. It could be a used car.
Since year one, so it's.
Well, you're one of you having it, maybe.